Okay, you might want to look at page 8 as I go through this with you. This is going to help you figure out how the pH scale is related to a logarithm and the hydrogen ion concentration in a solution. So if you take a look, our pH scale goes from 0 to 14. What I want you to take a look at is the chart on the top of page 8 that says Understanding the pH Scale. If you notice, when the pH is 1 or is 0, this relates to the hydrogen concentration in that particular solution. So a pH of 0 means that the hydrogen ion concentration is 1.0 molar. Okay? Now as our pH goes up and gets closer to 7, remember 7 is neutral, you are going to have less hydrogen ions because the solution is becoming less acidic. Alright? So if you look at the pH of 1, it tells us that the hydrogen ion concentration is a little bit less. It's 0.1 molar. And as you go up the pH scale, you get a lower, by times 10, a lower amount of hydrogen ions. So with a pH of 2, you can see that it's 0.01 molar. A pH of 3, 0.001 molar, and so on. What I'd like you to do is, on that chart, turn those numbers into scientific notation. So for example, if we take 0.1 molar, let's write that as 1.0 times 10 to the negative 1. Okay, so go ahead and do that for all of those on that chart on page 8. The next thing I want to do is show you how to use this in the pH equation. So we talked about in class that the pH equation equals the negative log of the hydrogen ion concentration in the solution. So let's start with just the whole numbers on the pH scale. So I know that my particular ion concentration is 0.1. I'm going to use this as my example here from before. I can find the pH if my concentration is equal to 0.1 molar. So negative log of 0.1. And if you plug that in your calculator right now, do it along with me. All right, negative log of 0.1, my answer is 1. Now we'll talk a little bit more about the logarithmic scale next time you're in class. But that means the pH equals 1. So that's how those two are related. Now, if you don't have a base 10 in your concentration, it's going to be a little bit different. So today in class you had a molarity of 0.75. Okay, so if I turn this number into the negative log of 0.75, because that was our concentration of hydrogen ions, if you plug that into your calculator, the negative log of 0.75 is 0.12. All right, so that would be the pH of this particular solution. So you're talking, way down in the strong acid, very, very close to 1 on the pH scale, or close to 0, I should say, sorry. So very, very close to 0 on the pH scale. So that makes it a strong acid. You can also go backwards. So if you are given the pH of a particular solution, let's just say that we know that the pH is equal to 3.7. All right, of a particular solution that you test. I can find out the hydrogen ion concentration by doing the exact opposite of the negative log function. So, if you are trying to solve for the hydrogen concentration, we do what's called the inverse log, which is also considered 10 to the whatever your pH is. However, you need to make the pH negative, and you'll see why when you calculate this. So it's going to be the inverse log of the negative pH. All right, so 10 to the negative pH is what you're going to put into your calculator. You're going to use the second function in order to do this. So if we plug in 3.7, all right, the hydrogen concentration would equal the inverse log, so 10 to the negative 3.7. So let's plug that in right now and see what we get. I'm going to hit my second function, and then log negative 3.7. I'm getting a concentration that is a very small amount, 0.0000199. I can write this in scientific notation as well, or your calculator might put it out as that. So I could write it 1.99 times 10 to the negative 4. 1, 2, 3, 4. Now, this particular answer, I need a unit of molarity because it is a concentration. It's a hydrogen ion concentration, so that's why I need molar as my unit. I'm going to quickly show you how to use your log function on the scientific calculator. If you haven't yet found it, you're looking for a small button that says LOG, and we're going to use that. If you look on this particular scientific calculator, you're looking in the upper left-hand corner. If you have a graphing calculator, your log function is right next to your number 7. So if you take a look at page 10, let's make sure we know how to plug this into our calculator. These are some of the practice problems that you're going to be doing. So I added one at the top. The hydrogen concentration is 2.4 times 10 to the, that should say, negative third power. We want to find the pH of this particular solution. So that means we're going to need to use negative log of 2.4 times 10 to the negative third power. So let's take a look and see what that looks like when we put that into our calculator. All right, negative log, and I'm going to put in 2.4 times 10. Remember, just like Avogadro's number, I'm going to use my second E for times 10, and then negative 3 equals, and I get 2.62. Sig fig counting, you're going to go by the number of sig figs that you're using from the molarity in this case, which is 2.4, so that's 2 sig figs. So if I look back to my calculator, I can use 2.6 as my pH answer. So our pH equals 2.6. So that should help you on the first couple questions there. We'll talk a little bit about pH, but if it makes sense to you, pH is just the measurement of hydroxide ions in solution rather than measuring the hydrogen ions. So in this case, they're giving you the hydroxide concentration. You're going to plug that into the negative log of the hydroxide ions. Now when you get to the bottom, you are doing the inverse logs. So what we talked about before. So now you're going to need to use your second log function. So when I mentioned that earlier, here's your second button and here's log. So when you plug that in, second log, you'll get like a 10 to the exponent sort of symbol with that caret. If you're using a graphing calculator, same thing, your second button's here, and then your log function. So when you plug that in, just make sure you make the negative pH. So for this one, I would type in 10 to the negative 4.8 to find that concentration of hydrogen. If you have any questions, post them on Schoology.